give everybody time. A quick straw poll. Who here has done any Perl6 coding? And I know there's at least, a few. Okay, cool. So if you've done a lot, you're probably not going to learn anything new from this. You might do. I've tried to get quite in-depth into things. But if you've only done a little bit or you haven't done any, then hopefully you will be able to pick up quite a bit about how Perl function calls work and method calls work. Right, time. So anybody else turns up, like my boss who said he would be here, they'll just have to miss the business. Yeah. Well, yeah, it's his problem. So, hi, I'm Simon Proctor. I'm known as Simon anywhere I managed to get the address before someone else stole it. And that's Simon as in science, not someone once pronounced it Simon. I'm like, no, not like scissors, science. I'm a senior developer at Zoopla. We are hiring. Feel free to go down and chat to the guys. It's a great place to work. I really love it, and I want more people there, preferably ones who are interested in Perl6, because then I can get us developing it. And this is Jared. He's my boss. He's not that late. It's fine. Look, I told everybody we're hiring. It's great. And feel free to come and chat to me, and we've got a couple of my other colleagues are here as well. They'll be able to tell you just how awesome it is to work there. So I gave a talk, as I said, at London Perl Workshop last year. Everything good? Yeah, cool. Talk at London Perl Workshop last year where I basically was all of the whiz-bangy stuff about how awesome. The video's on YouTube, you can look it up, it's quite fun. But one person after the talk said, it's all very well, we keep getting these talks about how awesome Perl6 is, but I'd like some real meat, I'd like some technical information. So I'm like, fine, okay. So I'm going to go through basically as much as I can sort of put into 50 minutes on how Perl6 function calls work. So the first part is signatures. Now, if you've used any more modern Perl5, then signatures are available. I think they're finally not experimental, but Perl6 signatures are a bit more impressive. So the first signature we've got is no signature at all. If when you define your subroutine or method, you don't put brackets after the name, then it will basically fall back to Perl5 mode. And it will put any arguments you pass in into the @_ array, and it will then, you can access it that way. So if you've got some old Perl5 code, you could just cut and paste it in and it might work. Some bits of it will. But this will work. I would not encourage using this. Do not write new code that uses this thing because you're missing all of the power that you get from the signatures. So yes, it is valid, don't do it. Also, if you do it, you will have a problem if you try and use fat arrows to pass in values, because it will think that you're actually trying to pass in a named argument and it will error. So if you want to use like the good old Perl5 fat arrow syntax to do stuff, you actually have to wrap your arguments in order to get away with that. So don't do this. Just don't use this. I wanted to put it in for completeness, but really don't use it. The empty signature. So here's the next one. So now we've got some brackets. And the empty signature basically says this subroutine or this method either doesn't take any values, doesn't take any arguments. And if you try and call a subroutine that has an empty signature and you pass it any parameters, it'll error. Depending on when you do it, generally it'll compile time error it. But it doesn't mean that this is just a constant, because you could have a state value in there that's like incrementing or something. You could this could be a method and it could be accessing self, which is automatically passed in. You don't have to pass self in when you're using a method. So you can access self and you can access attributes. So this isn't just a constant, but it is you aren't passing any arguments in. And like, as I said, see, methods. I should really remember what my slides are. This will happen a lot. So yeah, you have access to self. You also have access to the $alias, which is another way of referencing self within a method. Now we're on to actually passing some arguments in. So the easiest type of arguments are positional arguments. You just lay them out and they then get passed in automatically. You don't need to my them or anything like that. They're just passed across. And the arguments are lexical. They are, you can't modify them. They're immutable unless there's ways you can make them modifiable. Hello? Yeah? Question? Was there a question? No? Was it a comment? Okay. And this will error unless you pass exactly the same number of arguments. And as we go along, you'll see ways around that. But if you want to have 3 arguments, then that will do it. Boom. Nice and simple. Everybody with me so far? We'll go on to the next one. If you're doing a method call, you can reference the self object, and you can give it another alias. So in this case, I'm saying I want to access my my self object, but I want to call it foo, and I do that, and I put a colon as the separator between my my self object and then the rest of my arguments. By itself, this doesn't look really that useful. I mean, yeah, sure, if you want to call your object foo, but there are use cases for it later down the line. This is the whole thing with this, is as we go along, I'm going to be building on the stuff I've shown you earlier. So just remember that this is an option that you can do. One specific thing you can do with it is you can use this as a way of specifying class methods. And I'll explain that hopefully later. If not, I'll explain it at the end. Now, sometimes you don't want, well, you want maybe 2, but maybe you want 3, maybe you want a default value and such like. So in this case, I'm defining 4 values. The first one is required. Positional arguments are required unless you say otherwise. The second one is optional. Stuck a question mark after it. I'm saying you don't have to supply this. If you don't supply it, then it will get set to any, I believe, which is like the sort of undefined value. There's one, it's almost the base object. There's mu. Yeah. Yeah. The third one, we're setting our third value C to be 5 if you don't supply a value to it. So if I call this, like say here, I do 1 and 2, I get my C value is set to 5. Nice and simple. I quite like the last value over there, $D, because I'm basically saying, well, the value of $D is double the value of $C. The default value for $D is double $C. I can reference my variables within the signature. And like I say, later on when we hit type constraints, that can get quite powerful. You can do some quite impressive stuff with it by playing around with stuff in the signature. So. Yeah, oh yeah. There's a few of them watching, hopefully, on video right now. Hi, guys. And girls, of course. Yeah, I think I've covered everything there. So, now, when you're parsing, now there's a whole section on types, but one of the earliest types of types you get with in Perl6 is sigils. So you've got the dollar, which I've been showing already, which is for basic scalar values. That can be pretty much anything. It can be an array and a hash, but you can also use the @ symbol and the % symbol to signify either a positional or an associative role, which is generally an array or a hash, but it could be a list or it could be a set, and there's a few other things that fit into those buckets. Now, the important thing to note here is if I'm saying at A, then I'm expecting a list object. I'm not expecting 2 values in a list. So that's going to error because I'm passing in two positionals. To get it to actually accept that as values, I have to pass in as an array. And again, there's more to this. Because you've got flattening, Slurpy. Now, there's 3 different ways you can change that to instead say that take all the rest of the positionals in this argument call, in this function call, and put them into this array. So the single one flattens the remaining positional arguments. So here we have that array gets flattened down to a list, that list, or that gets flattened down to 2 elements in that array. The list over there also gets flattened down. I don't think it goes more than 1 level deep recursive though. I'm pretty sure. Yeah. But the easiest way of doing it is play around with it and test. That's what I generally do. You've got the non-flattening Slurpy. Similar thing, except for this time, rather than flattening our values, we keep them at the same thing. So in this case, this array stays being an array, that list stays being a list, so on and so forth. Okay? With me so far? And then we have the single rule Slurpy, which if there's one iterable item, then it flattens it into an array, otherwise it doesn't flatten it. This is the one that I always kind of get confused about. I do see the point for using it, but I always kind of get a bit confused about it. I would definitely recommend reading the documentation on this one. But those are 3 different ways of taking all of your parameters and slurping them all into a list. You can, of course, combine these. So you can say, well, I want one positional parameter, and then I could have more, and that could be 0. So this is basically going to take one or more positional parameters. The first one will go into A, and all the rest will go into at B. Nice and simple. Yeah, your Slurpy has to come last because, of course, it's going to get very confused if you try it, because, like, you ask, yeah, it just doesn't work. Don't try it. Named arguments. So as well as positional arguments, you can have named arguments where, sorry, and in this case they work the opposite way to positionals in that if you give a named argument, they are optional unless you specify they're required by putting exclamation mark after them to say this is a required argument. They go across lexically. So in this case, the name of the key is going to be A, and I can specify it in any of the different ways you can call a pair, and the value goes into $A. So that's how you access them. So if you're used to doing a lot of like Perl5 method calls where you pass in hashes, this kind of maps to that sort of. Now this is something I really like. If you can have alternate names for your named arguments. Now this is very useful when you're dealing with command line functions. So if you're putting something in the command line, you can have the long version or the short version of because named arguments when passed into main basically go dash dash, and that's how you specify them as named arguments. So you could have bar or B, and then either if you call this with either bar or B set as your key, it will be set to the B value. And you can nest them quite a long way down. I believe that's not a great idea though, because after a few levels, I think Zofix wrote a thing about this, after a few levels it gets very slow. But you can, and it's also quite useful if you deprecate a naming convention. So you want to change the name of the variable, but you want to have a little bit of time where to give you a chance to find all the places that are calling it and update it. So there's another way you can do that as well, which I cover in one of my bonus slides. You can also have positional and named arguments in the same argument list, which is all nice. And you can also have Slurpy positionals and have I shown Slurpy positionals yet? Did I miss Slurpy? Oh, yeah, there we go. Yeah, you can combine them all together, which can be useful, especially if you want to have flags. So if you want to have a function that you call it and you pass in a bunch of things and then you have some booleans. Hello, yes?
What would happen if you put the named argument, which is not required, as a first argument in this?
Yeah, you have to put the positionals before the named arguments. It doesn't like it.
Declaration you do, but in terms of passing it to the
Oh, yeah. Yeah, when you call it, it doesn't matter. Yeah, but when you're defining the signature, you've got to do it that way. Thank you, Larry.
Named arguments and defaults is also possible?
Yeah. You can also have a Slurpy hash, which will basically take any named arguments and pass them in. So they just sort of the things. Note down there we have how to do a Boolean named argument. You basically just pass it in with the name, and it sets the value to true or false for not A and not B. That's quite useful. So this is the first time I'm going to mention constraints, where you can, in your subroutine, you can say, well, this subroutine has to follow a certain rule. So in this case, I'm saying I'm expecting one positional argument, but it's got to be greater than 10. Now, who here has seen the wonderful star whatever code thing before? A couple of you, okay. Yeah, funny that. So in this case, the star is like a magic thing in Perl6. Depending on where it turns up, it has different powers. In this case, what happens is the grammar, the parser sees it and goes, well, I'm expecting a block here, and I've been given a whatever code. So what I'll do is I'll turn that whole chunk into a block, and that star will be, I think in this case it will be $_, but it doesn't really matter. Basically, it wraps that and turns it into a block. So you don't have to put a block there. You can just use the star, and it will do it by magic. Doesn't always work. There's a couple of places where you actually need to put a block, mainly if you're dealing with junctions, because they get a bit weird. Or ranges, yeah. You can have multiple where clauses, so you can. It's where you've got to specify multiple things that you can do. Now, at this point, constraints aren't amazing, but they will become better as we go along. Like I say, we're starting on signatures, but they're still types and they're still multi-methods. Constraints by themselves, you're basically got a function that if you call it wrong, your system dies. It's not great. You can eval it, I suppose, but not great. Oh yeah, like I say, you can chain your where clauses. That was fun. Hey, look, it's prime. Again, in this case, that basically applies or calls the isPrime function on the argument that's coming in. If I could also put dot question mark, though. In this case, like I say, I want it to error, so it's not prime. Or not an integer, but of course we haven't got types yet. I need to take a breath. Right. What you can also do, and this can be quite useful, is you can assign subsignatures. So when you've got a positional or a associative object, you can define the signature that is then applied to that object. So in this case, I'm saying I'm wanting an array, but it can only have 2 values. If I put a third value in, it will fail that subsignature. So this one works. That doesn't work because it's not an array. That one doesn't work because it's 3 values. And within the function, I can reference all 3 of my variables that I've defined in the signature. So I can reference @A, I can reference $B, and I can reference $C. If I don't want to reference @A, I could just use an @ and then it will just kind of ignore it, but it will look at the subsignature and pull the values out from that. One use I found, it's quite nice for this, is for recursive functions, where you're wanting to like head a list, because then you can have $B and then star at rest, and then do stuff with the head of the function. I wrote a lot of Prolog in my youth, so I like head on occasion. That came out really badly. So a signature on a function is an object. You can look at the signature and you can poke around it and you can see what it is. You can't modify it. You can't assign a signature to a function later on, or if you can, I haven't found out how to do it. I don't think you can though. But the opposite to the signature is the capture. And a capture is a special object that is both positional and associative. When you request it positionally, you get any positional arguments in it. When you request it associatively, you get any named arguments in it. And you can create captures and then pass them in to functions directly. And there's some powerful stuff you can do with that when you start doing call same and stuff. You can modify your capture or create a new capture and send it on to a later function call and everything. I'm not going to go into it too much more detail. I just wanted you to all be aware that this is when we get into the really deep code stuff. If you want any more info, check out the documentation. It's awesome. We keep adding more and it's really great. So that's signatures. Any questions on signatures before I move on to types? Yay, great. Doing right. So, simple types. Now we've already covered, like I say, arrays and hashes. But in this case, now I'm saying, right, for this I want an integer. And if I call it with anything else, it's going to error. So that's the really easy way of defining that you want a specific type. Now the thing to look out for is if you are passing in, like for instance, a positional, if you specify the type, it's not going to say, I want an array where everything is of this type. What you're saying is, I want an array that has been specifically defined as an array that holds this type. So that can cause you issues. I can't remember if I put a slide in about it, so I'm mentioning it here. That can cause you issues if you're trying to use a Slurpy and you want integers. you need to use a constraint to check them rather than saying I want integer Slurpy, because they won't be a typed array sort of thing. But yeah, so that's the basic type of typing. Then you've got type coercion. So now I'm saying I want something that could be an integer. It may not be an integer when you give it to me, but I can make it into an integer. And what this will do is this will call the int function on the passed in object if it exists and attempt to coerce it to an integer. So 5 works. Bob doesn't work because Bob can't be an integer. But 5.5 becomes 5 because when you coerce a float or a rational into a integer, it just gets rounded. And again, complex number, it's complex or whatever they are, exponential, pops into an integer, and also a string that could be an integer gets coerced into an integer. So that allows you to do be a bit more loose about the types you're wanting. You can be even looser, or you can be a bit more controlled by saying, well, I want it to be numeric in this case, but it then becomes an integer. So within the function, it's an integer, but it has to be some kind of numeric type. And at this point, our 5 string stops working, but all the others carry on working because they're all numeric types. Now, as it says up there, the bit when you're calling type without any brackets in, so when I was calling int without any brackets in, I'm basically saying int any. That just sort of gets put in there. But this allows you to, like I say, be a bit more controlled about your types. You can also specify the return type for your subroutine. And if you're for whatever reason you don't return that type, you'll get a runtime or compile time error depending on if the compiler can work out that it's not going to work. So these can be quite useful, and they will help the compiler to speed things up, I believe, or the VM to speed things up. Constraints are back. So here we have, again, we're doing another constraint where I'm saying I want this to be greater than 5, and that all works fine. So here we've got 2 constraints, basically. We've got a constraint to say it's got to be an integer, and we've got another constraint to say it's got to be greater than 5. Now, those are OK, but at this point you get to make use of, I did put that slide next, you get to make use of subsets. So a subset allows you to basically name a constraint on a type. So what I'm doing here is I'm saying I want effectively a new type that I can use in places that's called int over 5, and it's got to be an int, and it's got to follow this where clause. So it's got to be greater than 5, and now I can refer to it here as int over 5. Now, the important thing to note is that actually within the code, if this was saying a.what, which is the capital what, which is the introspection to say what kind of object are you, that would say int. It wouldn't say int over 5, it would just say int. But this allows you to, like I say, have if you're going to be using the same constraints over and over again, subsets are the way to go. I think you could do subset of any, so you could. And you can also chain where clauses onto that if you really want to. Like, it can get very, very, very crazy. So here's a nice little fun one. You can't have a so this is basically if you wanted to have a constraint to be wanting more than one type. This is the only way I found to do it at the moment, which is to basically have a where clause of the parent role. And then and this is what I was saying about how if you do that as whatever code with a star, that will break horribly. Or I could use call. But then I wouldn't be able to show off a junction. I like junction. Yeah. So this and you can do this for other type of things. So if you're needing multiple types, especially if you've got your own object system and you're wanting different objects coming in, then this is a way you can basically group together certain roles that aren't, or like remove other roles and stuff. Type captures are quite fun. So sometimes you want to take a type, but you don't actually mind what type it is, but you want it to be similar to other types in your call or different. But you can do this by using the double colon and then a signifier. And then when you use that signifier again, it basically says using the same type. And again, this is got some extra documentation on it because you can also then specify another type, and that would have to be different, and all this kind of stuff. And the nice thing with this is that again, this is the kind of thing where it will fail at the call time. It won't. One of the things I like with signatures is it allows you to move a lot of the complexity of like checking your code out from the or your data out from the beginning of your function call and into your signature. And it means that your actual function calls become smaller and become the actual code rather than stuff to mess around with things. So I mostly put this one in here because it is, I don't think I've ever actually used mime captures, but I've only done 6 modules so far, so I will do it at some point. And I threw that one in there because it was a thing and I thought I really should mention it. But as you can probably tell, I'm not 100% sure how to use it. Yeah. I'm just going to have a quick coffee. All right. I'm talking too fast again. I'll try and sorry, I do talk too fast. Like I say, has anybody got any questions on types before I move on to what's called? No? Cool. So multi-call is, for me, where everything else in the signatures suddenly just gets revved up to the next level. Everything suddenly gets so much more powerful. So a multi-call basically allows you to define the same subroutine or method with different signatures. And then at the time when you call the function, the VM will work out which version of these you wanted to call, and then do that version and stuff. And yeah, it allows you to do things like this, where I'm saying, well, if it's an int, I want to return A, but if I passed in a rational, then I want to round it and then return it and stuff. The important thing to note is that the return constraints aren't included, so you can't just define 2 versions with different return constraints and assume that because the caller wants a rational, it will call the one that returns a rational. That won't work. And where clauses are included, but not directly. There's the way where clauses work is a bit weird. But anyway, so that's a basic one. One of the fun things with multi-call is that it then allows you to put constants in. I don't know if anybody was at the talk just now about Crow, building a web app with Crow. But one of the things that Crow uses quite a lot is, Crow basically, the paths in Crow are signatures. And when you have a constant in the URL, it's just a constant, because when you've got a multi-call, that's how the matching works. So in this case, hey, Fibonacci sequence in recursive. Don't do this because it's really slow. There is a way you can make it a bit faster by adding caching, but the fastest way to do it is actually just the Fibonacci sequence using stars. You see, stars, gotta love them. But yeah, so in this case we've got if I call my function with 0, then it returns 1 because that's the first value, because it's basically treating it as an index. So if I call it 0, it returns 1. I call it 1, it returns 1. If I call it with anything else, uint is a defined subset of int for unsigned int. Great. If I call it with any other unsigned integer, then it basically recurses back. Brilliant. Of course, like I said, if you call that with 25, that's going to take a while because it's not going to cache it. There are ways of making it faster, but I've still not managed to get any of them faster than just doing it with the array. But I wanted to just show that you can use constants. You can also define prototypes. So in the case of a prototype, this basically allows you to declare any inputs or any parameters that are shared amongst all your different multi-calls. Now, if you don't declare a prototype, then you get the prototype, which is basically just proto subroutine name, the bar, which represents the rest of your capture, and then the star, which in this case is call the rest of your function. Like I say, star just does everything. It blows my mind how many different things star does, depending on where you find it. But it allows you to, one of the things you can do is that if you do define a prototype, you can actually put code in there, which will be run on any of your multi-calls, and then wherever you put the star, that's where the actual multi-call code will be run. again, you may not need to do this, but it can be useful. If you, as I've noted there, because I was running out of space, I dropped the subs out. If you don't put sub, if you just write multi and then a name, it implies you're wanting a subroutine. If you want a multi-method, you have to write multi-method foo, because you have methods on objects. But yeah, so this allows you to basically define these are the first value is always an integer. It's called a, and then we don't have to play around with it anymore. Only. Only is quite useful if you're going to have a large code base, or if you want to make sure that you don't mess up. If you know that a subroutine is not going to be a multi-call, if you define it with only, then if you later on make it a multi-call, it'll error in the same namespace. So it allows you to basically protect yourself, and a lot of the core code is written as only to stop like things breaking everywhere. I threw that one in for a bit of a laugh. I've gone way too fast. So here's a few. So now that's. I mean, this is the thing: is the actual multi-call bit. Once you've got the concepts of signatures and types, the multi-call is quite simple. It's like you have different signatures. It will call the one that matches. So here's a use case for multi-calls that if you don't have a poke around in any of the GitHub things. I mean, like Zeph's a good one. MI6 is another good one. Any of the Perl6 repos that provide you a command line script, you'll generally see something like this. So this would be the whole of the actual command line script. We use our library. Very important. If you're writing any Perl6 code, use modules. Just your script should be really small because modules get precompiled, which means that their parsing is not an issue. If you have a massive script, that's going to take a while to parse, and you'll be like, oh, Perl6 is really slow. It's not. You're writing about Perl6. No, you can. It's fine. It's not going to be fast. This dynamic variable sub main opts. This basically allows you to put named values anywhere in your when you're calling the function. So now looking, oh no, there I've got help. So this would allow me to call. I would call my command line script, and it's got a thing called action. And if I just call my command line script and I put action, so let's say it's called library for whatever reason. So library action, then it will call the action function because it's going to match this first multi-call. So the main method basically is the method that gets called when you run a command line script, and like I say, it can be a multi. If I call it with action, but I've also got a boolean called help that I'm setting to true. So I'm basically, and there's probably a better way of writing that. I'm looking at Liz's face. I'm thinking there's a better way of writing that, but what so if I'm passing in a help value, then instead of calling the action, instead it's called document action in my library to document the thing. So this is a very contrived example, just to show you though that multi-call in main is a great way of using it. It also lots of other places. I've been recently, one of the modules I worked on was Proctor invoke editor, which is 80% done. But you have an edit function, and there's 4 different ways you can call it. You can call it as a class method with a string. You can call it as a class method with a list of strings. You can call it as an object method with a string, or you can call it as an object method with a list of strings. 3 of them are simply so like the 2 class method ones instantiate an object and then call the string version by joining the list if it's in the list version. And the object version joins the string and then calls the string version. So 3 of them are basically one-line methods. And then the final method that actually does the invoke editor, which is about 6 lines, only have to do it once. It's really nice and really simple. And it doesn't have to do any complicated stuff of working out, have I been passed a string, have I been passed an array, all this kind of stuff. Nice and simple. So here's a slightly more complex example. So this is app MI6. This is pretty much the core code from MI6. So MI6 is the helper app, or the helper library for writing Perl6 modules. I love app MI6. I would not have done any Perl6 modules if this didn't exist, because it does all the hard stuff for me. It makes my meta JSON, it tells me I need a changes file, it uploads it to CPAN, it's great. One interesting thing to note is that this is just the code part of app MI6. The documentation, the pod documentation, is longer than the code. I like that. I'm a fan of documentation that's longer than the code. But here again, we've got the submain opt, we've got our MI6 object, and then we just have a bunch of mains with constant values going in, and some of them are just calling functions. One of you see, like this one's giving you the version on the object. At least one of them is, I think, erroring because it's not. Yeah, we've got over there upload is removed. Please call it release instead. So that's for backwards compatibility in that you've got to change how you're using the system. These slides will all be available. All app MI6 is on GitHub. Feel free to have a poke around and see how it works. But I think that's quite a good way of, like I say, writing this kind of thing. What do I have next? Oh yeah, well, so I've got 15 minutes. So I did a couple of bonus slides, which are these. I wrote these yesterday because I was like, there's a couple of things I would like to have mentioned if I had the time. I've got time. So one of the things is it's really easy to create new operators in Perl6. It's really easy. And these are all the different types of ways you can define an operator. So I'll go top to bottom. Infix is your standard. This sits in between another one. So here I've got my pound equals one, which basically takes a pound value and a US dollar value and then uses the approximately equal to check that the pound value is equal to the US dollar value divided by the exchange rate yesterday. So that's a nice one. Yeah, are these about the same map? Then I've got my prefix. So prefix sits in front of the thing. So in this case, you have a pound, you put it in front of a GBP value, and it will return you the dollar value. Nicely formatted, so you say pound 100 is $0.62, or it was yesterday morning when I wrote this. The postfix allows you to define an operator. Now note here, the exclamation mark is already an operator in Perl6. It's just, it's not a postfix operator, pretty sure. So what I'm saying here is, if you put a exclamation mark after an unsigned integer, it does the factorial of it. And it does this by, who's seen the reduction meta operator before? It's lovely. It's one of my favorite Perl6 things. So what the reduction meta operator is you take these square brackets, you put an infix operator in the middle, and then you put a list after it. And then what it will do is it will effectively take your list, and in this case the list is a range, but that gets spread out into a list. And it puts your infix operator between all the values and then does that calculation. It's again, looking at Liz's face. That's how you can think of what it does. It basically does a reduction, so on your list, using that operator. Depending on the precedence and the associativity of the precedence of your operator, it might work differently. But again, all documented, worth a look. And I quite like the fact that that's how to do a factorial. That line will give you a factorial operator. The circumfix operator lets you basically define start and end, like two operators that define a start and an end, and then you can put stuff inside them and it will do things. So basically that's how brackets are defined. They're a circumfix operator. So here I've got foo and bar, and it reverses the list that it's given to it and puts bar and foo the other way around. So foo 1 to 5 range bar gives us bar 5, 4, 3, 2, 1 foo. Totally useless, but I was running out of ways of things to explain how to do this. Yeah, probably. Yeah. I'm sure I tested it, but I probably didn't. And then you've got post circumfix, which is like a circumfix operator, but it's basically how like array referencing and hash referencing works. In that, when you call it, you give it the first value. So you'll call it with two values. The first one is the thing you're calling it on, and the second one is the index inside the value. So in this case, I've got my DD, where I give it a year, and then I give it a number of days, and it basically creates a date object, which dates are, for those who don't know, a built-in type in Perl6, no having to pull in extra modules. So it creates a new date object, adds on the number of days, boom, gives me the returned value. So those are all that's how you do operators. It's really that simple, and you can multi them as well. So I'm currently working on doing horrible things to the the set operators to deal with ranges. Because right now, when you've got a range, if you do set operators on it, and there is a whole group of set operators, if you do a set operator on it, it flattens it out into a list. But sometimes I want my range to represent the continuous range, not the individual discrete options. So I'm having a set of, I'm overloading all of the set operators so that if I want to do that, I can basically treat ranges as objects rather than flatten them out into lists. All the Booleans are done, and I'm working on the others. I released the first version of it yesterday if anybody wants to critique my code. Or look at multi-calls, lots of multi-calls. Loads of multi-calls. For all the different types of lists and values and stuff. So another bonus slide here. When you're defining your subroutine or methods, you can use what's called traits, which come after the signature, before the brackets, the curly brackets, to define your actual block of the code. And these allow you to sort of specify various stuff about them. So IsAssoc defines associativity. So whether it's left associative, right associative. The first, IsAssoc, IsTiter, IsLooser, is equiv. These are all generally if you're wanting to do stuff with operators and you want to say how that operator relates to other operators in the precedence chain. So these allow you to basically stick them in the right place. The chain and list ones are also quite useful when you're dealing with infix operators and you want to be able to use. You want to be able to use the reduction meta operator, and why wouldn't you? It's awesome. So yeah, those are good for that. And like I said, all of these are documented in the operators. The routines part of the Perl6 documentation. Go read the Perl6 documentation, and you too can write an entire 40-minute talk and make it look like you know what you're talking about. No, IsPure is really nice. This basically says that for this set of arguments, I will always return the same result. So you're basically flagging to the VM to say, you can probably inline this if you see it being called. Don't use it if you have side effects in your code. But for instance, like say, I'm doing this stuff with ranges, and if you've got is the number 1.5 in the range 1 to 10 using the element operator, that will always return true. It's never going to be false, so I can say pure on it, and then it will speed things up. So that's great. IsExport, if you're writing a module and you've, as opposed to a class, and you want to be able, or role, and you want to be able to export subroutines from it, then you flag them as export. There are a bunch of options for how you do that, so you can flag things as these are always exported, which is the default, or you can say these are exported for these certain situations, so it allows you to do named importing like you could do in Perl5. IsRW, very useful if you're dealing with returning hashes or arrays, because what this will allow you to do is do a function call, and then that could return a point within a hash, like hash reference, and then you could do equals a value, and you could basically assign directly to the result of that. I think that's how it works. So yeah, basically saying the return value is read writable. Is deprecated. It's great. You can basically put deprecated flags on your subroutines, and then if they're called, it will throw warnings up. Like I was saying, if you had a subroutine that had a name and you wanted to change the name, you could basically make it the two multi-calls. So the first multi-call is the code that you want to have with the new name, and the old one has an is deprecated on it with the old name, and then that just calls the same with the new name sort of thing. And that way you see that you can see the warnings, you can track down all the places you're calling it with the old name, and eventually you can get rid of the deprecated code. Another awesome idea. Wonder who had that. And then finally, is hidden from backtrace. I included this just to be consistent with all the things that are there, or complete. That's the word. If you put that on a function, then if your system generates a backtrace for any reason, like you have a warning or you die or something, then that function will just be skipped in the backtrace chain. So and it can be useful. I mean, we've all seen those massive backtraces created by something like Mason, and like most of it you don't give a monkeys about. So if something isn't actually important to the running of the code, if it's like a logger or something, then just stick it is hidden from backtrace. There's another one that I didn't include on there because it's experimental, but it is also awesome, which is cached. Like I said, it is experimental, but you can flag something as is cached, and then it effectively wraps your code in some caching routines. And if you put is cached on the Fibonacci recursive, suddenly a lot faster. Still not as fast as the list. Again, I'm going to link I'll be putting these on SlideShare later on today, but here's a few basically things I read in order to write these. So we've got the signature documentation in Perl6 docs. Love the Perl6 docs. Again, the functions and the capture documentation. So this is literally where I got the core of this talk from. Plus also trying lots of stuff out. Pretty much everything I did in the slides, I did try on the command line at least once to make sure it worked the way I thought it did. There's a few books here. So think Perl6, which is a really nice sort of introduction to Perl6 programming. Cool, 5 minutes, doing good. Introduction to Perl6 programming book, which is downstairs. I was going to say it's downstairs. And Lauren, you wrote it. Yeah, it's a great book. I love it. That was like my first Perl6 book. It's awesome. Perl6 Deep Dive. Who wrote that again? Is it Moritz or was it? Yeah, Andrew. Yeah, Andre Shitop. Great book. Goes into really large amounts of detail about lots of stuff in Perl6. Again, I believe both of them are downstairs or upstairs. Upstairs. If you want to read them. And then finally, Learning Perl6 by Brian Foy is in pre-order now. I've kickstarted it, so I've had a look through and the PDF, and it does look really quite good. Again, goes into quite a bit of detail. So. Yeah, there we go. 5 minutes till lunch. Any questions?
Yes, you have 4.5 and the signature was 8, so you get 4.
If it's into brackets. So if the signature's int and you pass in, so the question was if you have 4.5 and the signature is int, you'll get 4. Yeah. Yes. So if the signature is just int, that will error because 4.5 is a rational, not an integer. If the signature is int brackets, so that's the coercion type, then it will coerce it to an integer, which will round it down to 4. Okay. Any other questions? Hello? No? Yeah?
When you have alias name parameters,
Yeah?
can you tell what name is used?
I don't know. I don't think so. I was looking at Liz, and Liz was sort of shaking her head, so I'll go with a no. Any other questions? Yeah, that would do it. Look at your yeah. Or do you just split them into multis and you can do it that way? Hello. Yes, Proctor.
Yeah, so you, for example, I want to write all in the bottom,
Yeah.
and after that, all some multi.
Yeah. Well, so in this case, like I say, if you wanted, you could put a warning, for instance, in. So that could be warn. I've been called with this. And then the star, and the star would then call down to the actual multi-call that's getting passed, and you can put it in. That works, doesn't it? There's other places that works as well. It's quite fun. There's also, and I didn't mention in these, there's a whole section of there's call same, call with, and others which allow you to basically redispatch the call with different parameters, or try and redispatch the call with the same parameters and stuff. Again, it's all documented. Worth having a look. Any other questions? Because I need a drink. Yes.
What happens if you have
If you have a star multiple, I have no idea. Try it out and see what happens. Sorry. Yes. Uh-huh. That's always good.
It's powerful not to actually write your own Proctor or say Perl or Perl, the place where you can simply declare sub, line out, carry, and then the technique you use here, along with the new phrases like creating instructions.
Oh yeah, there's all kinds of crazy stuff. Look, if anybody wants to grab me during the thing and talk to me about it, I love talking about Perl6 and Perl5, but mostly Perl6. Liz, hello. What did I do wrong?
Really a comment,
Uh-huh.
I think you're looking too far ahead with regards to the value of the pound towards the dollar.
Yeah, I'm always hoping. I managed to not have any Brexit jokes in it. Aren't you impressed? I'm keeping them for later. Cool. Anything else? Anything else?
I'll point out that
Thank you, Larry.
both actually work.
Yes. Oh no. Yeah, that's very true. I deliberately left them in, and this code you can copy it. Yeah. Oh. Yeah. You can't trust these things. Curly quotes. The number of quotes, the number of things that are valid quotes in Perl6 is hilarious. Some of them are beautiful. They really are. All kind of curly things. Yeah. Anything else, or can we go and eat? Hello. Yes. Fibonacci slide. That was Constance. Yes. So what will happen is the first time you call that, it will define the. I can't remember what I made it say. I think it's just so that it doesn't have to re-go through it and stuff. Yeah. Yeah.
Because it's lazy,
Yeah.
if
Yeah.
you call it with large numbers, it tends to make more.
Yeah. It's all
I
good.
have actually
Yeah. No. Questions are good. I like questions.
The question about the multi version.
Yeah.
If I use, I don't remember what.
Is cached or is pure?
No, I'm
yeah.
asking about like next with the same with.
Call with.
I don't-
Yeah.
I don't remember what exactly should I use here, but is it going to do the tail recursion optimization or not?
Don't think we've got tail recursion yet, but
By default, but that's those call same kind of calls are
right.
after that.
We'll get there. Cool. Well, I hope that has given you some insight into Perl6 and its power, and you're all raring to go to write some Perl6. And if you want to come and work at Zoopla and help me, because I need more people who want to write Perl6, so I can convince him that we should deploy some. I am not subtle about my underlying plans here at all. So anyway, hope you enjoyed it. Thank you very much.